Yeah, hi folks. I've changed my mind. I'm going to do example one. In the other video for this exercise, I think I've said I'm not going to bother with example one and two. But anyway, I'm going to do example one. I'm just going to derive the equations that we're already given. So the first thing all I'm going to do with this diagram is fill in everything that I know. What I want is an expression for this long side and this short side, looking at the big triangle ADE. And I'm going to do that, well, here we go. So the first thing I'm going to notice is that this angle here must be alpha because I have alternate angles. So that must be alpha. Because this is a right angle, this must be 90 minus alpha. And so of course, this angle up here must be alpha. Because this line AE is 1, then in the triangle ACE, no, that's not true. In the triangle CFE, this side here is it this side that I want? No, I'm gonna go back to this one. This AC is cos alpha because if you think about it, that's all cos beta. Cos beta is adjacent over hypotenuse, AC over 1. So I can write AC as cos beta. That's it. Cos beta. I'm going to draw right this side, EC, because if you look at my big triangle, EC is sine beta. That's it. Now then, I can look at this triangle here, and if you think about FC, well, the sine of alpha is FC over the hypotenuse. So sine alpha is FC over sine sine beta. So FC must be sine alpha sine beta. Sine alpha sine beta. And I can get an expression for EF because cos alpha is EF over sine beta. So EF must be cos alpha sine beta. Cos alpha sine beta. Okay. If I look at this triangle, ABC, well, the height, sine alpha, will be BC over cos B. Sine alpha is BC over cos, keep calling it B, I mean beta. So BC is sine alpha cos beta. Sine alpha cos beta. And of course, DF is also sine alpha cos beta. If I look at my triangle ADE, well, this here, ED, the sine of alpha plus beta is ED over 1. So we can say straight away the whole thing, ED, is sine of alpha plus beta. ED is sine of alpha plus beta. Well, of course, ED is EF plus FD. So we can write that the sine of alpha plus beta, the whole thing, equals cos A sine B. I'm going to go for this one first, sine alpha cos beta, sine alpha cos beta plus cos alpha sine beta. And we're given that. Incidentally, I can, and you're asked to do this in question 1, I believe, I can replace the beta with a minus beta and get an equivalent for alpha minus beta. Spoiler alert, all happens is you change that to a minus. If I look at AD in my big triangle, well, the cos of alpha plus beta is AD over 1. So AD is cos of alpha plus beta. So again, I can say cos of alpha plus beta plus sine alpha sine beta equals, what's this side here? It's, I haven't actually worked it out, have I? It's the cos of, no, let's do this one again. Sorry, AB over the hypotenuse cos beta is cos of alpha, so AB is cos alpha cos beta. So the whole length is cos alpha cos beta. Okay, so we can write that cos alpha cos beta is equal to, this is cos alpha plus beta, plus this length here, sine alpha sine beta. And if I rearrange this, I get cos of alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. They don't necessarily need to memorize the derivation because all we do is fill in what we know. I've never seen it asked to derive these, and we are given these, which is why my first response in the first video was, oh, I'm not going to bother. But I think it's worth seeing. Example 2 is, well, you can read example 2 yourself. All you're doing is replacing the minus b, replacing the beta with minus beta, changing the sign there, replacing the minus beta and changing the sign there, and it works it through for you. But you can have a look at that yourself. Example 2 isn't that hard. So there you go, just an extra for exercise, what is it, 7A.